ChatGPT failed me. How can I solve this? Okay, let's have a look. This question is from Reddit r/alevelmaths. So I think this is an A-level math question. And we are going to solve this exponential equation because the x is in the exponent. And the answer in the back of the book is this, so we are supposed to get that. So let's see how we can do it. First, we have 6 to the 50 minus x power equals 2 to the 50th power. I'm not going to multiply that out for obvious reason. But I will like to break this down though, and here's what we can do. If we have some base b raised to some power m and then minus another power like this, this in fact is equal to b to the m's power over b to the n. Usually we look at this from right to left. When you divide this and that, you subtract the exponents. But when you subtract the exponent, you can look at it backwards like this. So it's correct. So that's what we'll use. We have 6 to the 50th power over 6 to the x power, like that. And that's equal to 2 to the 50th power. Now we have this equation with this denominator. Let's multiply the entire equation by that denominator. Take this, multiply by that, we get 6 to the 50th power. Take this times that, it will just be 2 to the 50 times 6 to the 6. 6 to the x. Then, I need to isolate this part because this is the only part that has the x. So let me divide both sides by 2 to the 50th power here and here, so they cancel. Now check this out. 6 to the 50th over 2 to the 50th. Notice how the exponents are the same, right? So we can use another rule of exponent. Here's the deal. If we have a to some power m over b to the same power m, this right here is the same as you do a over b first and then raise to the power of m. This is okay. And in fact, usually we look at it from this direction to there. When you have this, you just distribute the power, but you can also look at it like this. So for this in particular, we can look at it as 6 over 2 and then raise that to the 50th power, and that's equal to 6 to the x power. For the inside, just work it out regularly. So that's 3 to the 50th power, and that's equal to 6 to the x power. So now we have the exponential part isolated, and usually when you want to solve an exponential equation, you want to first try to see if you can make the base the same. But 3 is just 3 times 1. 6 is like 2 times 3. So you cannot write this as 3 to some power, so it's a no-go, unless you use logarithm, and that's exactly what we'll use. And you can do it this way. I'd like to write this down first. 6 to the x power, that's equal to 3 to the 50th power. Now, what you want to do is, whenever you have the exponential equation b to the x power equals some positive number, you are going to take the log with the same base b to both sides. And remember, the input for log has to be positive in order to stay in the real world, otherwise you get an unreal answer. So right here, this and that will cancel, and you will just end up with x equals whatever that is, log base b of the positive number. So that's what we will do right here. We will take log base 6. This is my 6, this is b. Anyways, take this to both sides, and now you see this and that will cancel, and we just get x equals this thing, right? Log 6, 3 to the 50th power. Okay, so this is one logarithm rule that you have to know. But how about this right here though? Well, here's another logarithm rule that you have to know. If you have a logarithm with some base b, and let's say you have something like this raised to some power n, you can bring the exponent to the front and make it into a multiplication. N times log base b of that a thing. So the final touch is that since inside here we have 3 to the 50th power, we will take the 50, multiply that with this, right? Take that to the front. So final answer, x equals 50 times log base 6 of 3. All right, so that'll be it.